Hi, folks. Welcome back. So, obviously, benchmarks are really important to pushing forward agents and models. And these days, there's been a lot of activity around constructing voice agents, especially for scenarios like customer support. There's a ton of companies building them, a ton of startups are getting a lot of funding to work on this. And so it's really good to finally see a benchmark that actually end-to-end measures the performance of voice agents. There were a few benchmarks in this space, but they always left something to be desired in that they only tested one part of it, or they only looked at the transcripts and not the audio part of it. But this benchmark from the people at ServiceNow aims to look at the full end-to-end voice performance of a voice agent. So I want to look at this in a bit more detail. Thankfully, they have a GitHub where they have the scaffolding to run the benchmark and also the data sets for the benchmark. But before we even get into what the benchmark is, the mechanics of running it, we first have to talk about what they're trying to measure. How would you measure whether a voice agent is any good? And the authors here have zeroed in on two categories of metrics. The first one they call EVA, which is accuracy metrics. And here they're trying to measure if the LLM is behaving correctly. And they have three metrics under that umbrella. The first one is task completion, and this is simply a binary metric which measures if the agent achieved the correct result at the end of the conversation. They determine correctness by checking what tool calls were made and if the right tool calls were made along the way. However, that's not the complete picture. In addition to completing a task correctly, you also need to know whether the agent was faithful to the grounding given to it, the instructions and the policies of the company it's representing. And you need this because the agent might have completed a task successfully, but it might have lied along the way, and you don't want that. So faithfulness looks at the complete conversation to check if the agent is being consistent with the instructions and policies and grounding given to it. And finally, you have a measure of the audio quality itself to make sure that the audio, not just the transcript, the actual audio produced by the agent is accurate in that it has the right information that it's giving to the customer, things like confirmation numbers, dates, dollar amounts, and so on. So these three metrics measure correctness. However, that's not the full story. You also need to measure the experience of the conversation, the quality of the entire conversation. And so for that, they have a different set of metrics that they call the experience metrics. The first one under that category is a measure of whether the agent is making progress in the conversation, whether it's moving forward in the conversation, it's avoiding repetition, keeping the right context across multiple turns of conversation, and not just stalling or backtracking. The other thing to look for is conciseness. You don't want the agent to be overly verbose. And finally, you want some measure of whether the turn taking was appropriate. So measuring that the agent isn't interrupting the user, it isn't introducing too much dead air where you have long wait before the agent speaks. So this category of metrics is not measuring correctness, but it's measuring the fluency or whether the listener on the other end would say that this was a good conversation. Now let's look at the mechanics of how this benchmark is run. They have a full end-to-end, so audio to audio scaffolding for running these voice agents. So of course you have the voice agent, that's the thing you're testing, but they also use a voice agent to simulate the user. So you have a data set which describes these scenarios, and the scenario has information about who the user is, what their information is, what they're calling about, what is the resolution they want, and so on. And they use a voice agent. In this case, they use an 11 Labs voice agent to simulate the user. And the simulated user is talking to the voice agent that is being benchmarked. And then the output goes into an LLM judge that measures all these metrics that we just talked about. And in terms of measuring the metrics, there's a couple of different ways to do it. There's, of course, pass at one, which is where you run each data point once and see what metrics you get. But the more stringent metric is pass to the power of k, which means that you run one single data point k times, and you check if each of those times you got the same or similar output from the agent. So this is a test of determinism, which says that if I give the agent the same customer scenario, it produces the same resolution or the same output. And of course, this is a much more stringent test. A really good property of this benchmark is that it is agnostic to the models of the agents or even the architecture of the agents. So there's a couple of very common architectures that voice agents use. One is what they call a cascading architecture, where you transcribe the speech, you put the speech, the transcribed speech as text through an LLM, and then you get text out, and then you convert that back to speech. So that's a cascaded model. You also have agents that run within an audio native model. So those are the speech to speech, S2S agents. And there's usually a trade-off between these two architectures, because when you have a cascaded architecture, you can use a more powerful text-only LLM to do reasoning and tool calls at the cost of more latency, which results in the conversation sounding not very natural. On the other hand, if you use a native audio model, so you're not doing any transcription or text to speech on the other end, you're running the entire agent inside a native speech to speech, audio in, audio out model, you get much more natural sounding conversations. But because these S2S models are typically smaller than the full text frontier models, their reasoning and tool calling capabilities are less powerful. So there's a trade-off there. However, this benchmark is agnostic to the architecture because it's just looking at the output of the agent as a whole. All right, so how did the models and agents from the current era do on this benchmark? They tested several different agents spanning cascade as well as native speech-to-speech and even hybrid architectures. And you can see the kinds of models they use. They use Gemini 3 Flash and Gemma and GPT-5.4. And on the native speech-to-speech side, they use Flash Live, GPT Real-Time, GPT Real-Time Mini. And here are the results for the accuracy metrics. The pass at one metrics, the maximum any agent achieves on it is in the 50% range. And you can see that the speech-to-speech agents perform well on this. But notice how generally bad the scores are. They're all in the 10s and 20s and 30s. And if you look at the more stringent pass to the power of k metric, which, like I said, is a measure of repeatability, you get even worse scores. Almost every agent falls way below 10%, with just a couple of speech-to-speech models performing at around 20%. So this is good news in some sense because it shows that this benchmark is far from saturated and that there is still a lot of work to be done in terms of making these voice agents perform well. The story is similar for the experience metrics, where the pass to the power of k metrics are very dismal and pass at 1 is slightly better. They have some interesting commentary on the top reasons that performance is low on agents. One thing I found interesting was transcription accuracy is a bottleneck. They still found many cases where transcription of key named entities didn't happen, and that of course affects task completion. Another thing that stood out was that the native speech-to-speech agents have much higher experience scores, and that's expected because they're not doing transcription and text-to-speech in and out. But here's the trade-off we were talking about. The native speech-to-speech systems are not as powerful reasoners, and so they have issues with adhering to policy, and they violate policy more often than the cascaded systems. The other interesting failure mode was that even where task completion was high, there were a lot of issues with faithfulness, which is to say, did the agent follow the given policies? So this is a very stark statistic, which says that of the completed task data points, 72% had some policy deviation. So clearly a lot of work to do over there. All right, so that was a quick look at a new benchmark for measuring voice-to-voice agents natively end-to-end. I hope you enjoyed that. If you like content like this, consider subscribing, like the video, leave a comment, and I will see you next time. Thank you very much.